So lesson 9 for the 6th graders here, unit 1, and we're on page, looks like 75. So it's talking about the formula for the area of a triangle. So let's look at this here really quick. It says study the examples and non-examples of bases and heights. Now, right off the bat, I'm just going to do kind of a preemptive strike. And some of you know this already. The formula for the area of a triangle is the area equals 1/2 times the base times the height. Okay? That's the formula for the area of a triangle. So we can look at these first 3 examples they gave us here. And here's the base right here. This is the base. And then all 3 of these can be used for the height, because right here is the height. That's the top of that triangle. If this is the base, that point right there is the height. And Mr. Cross, would you shut that door for me? Thank you. Now, what's important that you guys recognize is that when you go from the base to whatever the height is, it has to be a right angle. And all 3 of these are a right angle. Now, the most obvious one here, this looks really good. It's on the base and it goes right to the tip of the height. But I mean, it doesn't have to fall inside the blue shaded area of the triangle. All 3 of these could be used for the height, as long as whatever you're measuring for the height is perpendicular to the base. In other words, it's a right angle. Okay, so that's a good example. Here's another one. Looks kind of odd here, but this is what they're using for the base. And then they drew a dashed line, and this would be the height. Now, if we looked at it this way, all right, then it might make a little more sense to you. This is a right angle, and this is for the height. Okay. This last one here, again, it's kind of a odd looking the way they've done it. But if this is the base, whatever the height is going to be a right angle to that height. Then here's the height right there. All right. So all 3 of those, you could actually figure out what the area was. So we have to do this? No. Now, these do not represent the heights. Notice this is not, I'm going to zoom in a little bit here. This is important, you guys. This is not a right angle. It's tilted. Okay? Yeah. If it was a right angle, it would be straight. Now, I could draw this, and I'm kind of guessing here. I'm just kind of eyeballing it. It's not perfect, but that would be the height. Okay? Not what they've got here. This also wouldn't work. Again, if I was to turn this around, and we're looking at that base, it's kind of blurry. Let me see if I can fix that. Okay. This is not a right angle here. It's tilted to the side, so that's not going to work. This one is a right angle, but does it go to the, no. Now, if it was over here, well, that would probably work.
Or if it went a little bit outside the triangle.
Yeah, it could be outside the triangle too. That would be fine. Yeah. All right. So down at the bottom of the page here, it says, select all the statements that are true about bases and heights in a triangle. Let's take a look at this. So we're on page 76. You zoom out a little bit. All right. Any side of a triangle can be a base. All right. That's true. I'm going to circle that. There is only one possible height. Now, they in the teacher's manual, they marked that as wrong. Yeah, exactly. That's what I was thinking, Mr. Harsh. I mean, technically, there's only one height. So I thought that was kind of confusing the way they worded that. But number 2 is supposed to be false. Number 3, a height is always one of the sides of a triangle.
Yeah.
Well, think about it. Is that's the height? Is that the side of a triangle? No. So cross out number 3. That's not necessarily true. Number 4, a height that corresponds to a base must be drawn at an acute angle. No. Now, I'm going to pull a stick here. Let me see here. Mr. Hanley, what's an acute angle? You remember?
I remember.
No? Okay. Miss Stevenson, what's an acute angle? You remember? No? Okay. So we're up to 30 points here. Mr. Dowler, 30 points. What's an acute angle?
An acute angle is an angle that's like less than a right angle.
Nicely done. 30 points for your group. So he said it perfectly. An acute angle. So here, this is, I know it's not perfect, but that's 90 degrees. That's a right angle. An acute angle is less than 90 degrees. And so let's look at the next one here. Well, no, I'll just keep going. And an obtuse angle is more than 90 degrees. All right. So right angle, acute angle, and obtuse. Obtuse even sounds bigger. All right. So number 4 here, a height that corresponds to a base must be drawn at an acute angle. So put an X through that. Number 5 here, a height that corresponds to a base must be drawn at a right angle to the base. Circle that, baby. That's true. Number 6, once we choose a base, there is only one segment that represents the corresponding height.
Yes, that's true.
Really? Is there only one segment that corresponds to the height in that? No, So that's not true. There could be multiple. They'd all be the same height, but there could be several line segments. Okay. And number 7, a segment representing a height must go through the vertex. So no, think about it. Now in this case, does it go through the vertex? Yes. But how about these two? Do they go through the vertex? Nope. Okay. So back to number 7. Cross that one out. All right. There's only 2 that are true. Technically 1 and 5. So finding the formula for the area of a triangle. So it says for each triangle, label the side that can be used for a base and a segment showing its corresponding height. So they're talking about these right here. And so they've done some of these for you. So I'm looking at A here, and I'll do the first one with you. So this is a right angle right there. And the base is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, and I can even just put it right here. I'm going to put area equals 1/2 times the base times the height. I'm just going to put a 10. And what's the height? 1, 2, 3, 4, 5, 6, 7.
6.5.
What's 10 times 7?
What?
No, it's not and a half. 70.
70. What's half of 70?
35.
Now, do I just put 35?
No, you put units squared.
35 units squared. 35 units squared. So there's A done for you. Now, look at C here. They've given you the height right here. This would be your base. Okay. How about D? They've given you the height here. What's the base?
4.
4. Oh, right. Yes. 1, 2, 3, 4. This would be the base. Okay. And so you're going to fill out this chart with that information. All right. Any triangle, base times the height, equals square units. Yeah, I'm not sure what they're, I don't know. Maybe they're just asking for the formula. Area equals 1/2 times the base times the height. Notice that sometimes I put them in parentheses and sometimes I don't. This is just fine like that. Anytime you have two letters, two variables, letters are called variables. If they're next to one another, they're being multiplied by one another. All right, so bottom of page 77, for each triangle, circle a base measurement that you can use to find the area of the triangle. So there's several here for you guys to do also. Look at letter C here. Want to make sure you guys are on the same page. What side, I'll pull a stick here. What side in C is the base? Miss Wagner, what do you think? What would be the base in? Yeah, nicely done, honey. Put up 20 points. So I'm going to just highlight that in red. This would be the base.
Didn't you say it could be both?
What's that?
Didn't you say it always can be both? Both can be the base?
I'm not sure. I'd have to think about that. But I'm going by what they've used for the height right here. If this is going to be the height, this would be the base.
I thought 3 centimeters would be the base and 7 centimeters would be the height.
Nope. Nope. But I mean, actually, if you reversed it, I suppose you. No. Well, how can I phrase this?
Yes and no.
Let's write down the formula. Watch. So area equals base times 1/2 base times the height. So area equals 1/2 times what's the base? 7 times what? 3. Okay. Well, is 7 times 3 the same thing as 3 times 7?
Yes.
Yeah. So reversing this doesn't really matter. If I was to use this as the base, I'd have to draw a right angle, and that would be the height. Okay. If this was the base, I'd have to draw a right angle, and the height would be out here somewhere. Okay. So I think you could use any of the 3 sides, but I'd have to think about that and look up some different angles. What's that, honey?
Are we supposed to find the area of these triangles? 3 of them. Find the area of 3.
It says at the bottom of page 77, for each triangle, circle a base measurement that you can use to find the area. Then find the area of any 3 triangles. Now, this is one of the things I don't like about this curriculum. Students are going to pick all kinds of different triangles, and then I have to figure out all 3 of them. All of them. So I just want you guys to do all of them. Do A, B, C, D, and E. Okay? Figure out the area for all of them.
Wait, can't you just say only A, B, C?
Nope. I'm saying all of them. So I want you to figure out the area for every one of them. All right, lesson summary. You guys know what that is. They're not asking you any questions. There's good information that you can use. How am I doing on time here? Gosh, only got 1 minute left. So page 79 is the lesson summary, and a little bit more on page 80, lesson summary. And then we have some practice problems here. And you guys should be able to do those. Select all drawings in which the corresponding height, and the height is going to be at a right angle in the dots for a given base, is correctly identified. So look at A, for example. If this is the base, could I use that for the height?
Yeah.
Let's turn it around. Look at it. It's kind of upside down. Where are we here?
Yeah, it's a right.
Yeah, it's a right angle. Sure. Yep. So for A,
Circle.
10 seconds already. Circle A. All right. So you guys finish the rest of this lesson all the way up to page looks like
85.